Testing, testing, 1, 2, 3, testing, testing. Checking the latency. Forgot to have my Ethernet cable in. That might improve the resolution somewhat. Okay. Chilled cow, you say? I will have to check that out. Okay. Hello everybody. Welcome to your lecture this fine morning/afternoon on a somewhat gray day in September. I am pleased to announce to the class that we seem to have finally settled on acquiring our third TA for this class. I will be issuing an updated version of the syllabus to include this new TA's information sometime this afternoon. But what this essentially means is that you don't have to look at my ugly mug again for one of the tutorials coming up next week. The tutorials will be both taught by TAs, which is fantastic because, you know, if we can't even get bloody TAs for the tutorials in time for the tutorials, it kind of makes us look bad, eh? It's been kind of a weird semester, though. I hope everybody is still bearing with us. There just seems like there's a stupid amount of administrative BS that's going on. But anyway, yeah, his name is Parker. He seems like a really cool dude, and yeah, so we will get that squared away. Aside from that, I should note that the tutorials next week are they are both going to be happening on MS Teams. We'll see if we can't get a recording of one of the two tutorials up on Avenue. There's a little bit of setup that has to occur with that, but we'll see if we can't do that, because I know some people might. It's very convenient for a lot of people to be able to watch this stuff back. So we will try to, at the same time, integrate recording and uploading of tutorial content, possibly to Avenue, possibly to probably Sorush's YouTube channel or mine. And that's how we will get things accomplished. So yeah, how are you guys all doing today? You guys doing well? You guys have any questions with respect to anything? Because if not, we'll get right into our lecture material for today. The audio and video is out of sync. Yeah, this is a problem that I was having earlier. I'm not sure that there's anything. Maybe I can do something about that. Maybe I can't. No, I don't think there's really anything I can do about that. Sorry. That's just the way it's going to be, unfortunately. So, good to hear that you guys are doing all right. So, when last we spoke, we were talking about some very overall concepts having to do with computer architecture, how data is stored, how computer programs are executed, and what the model of computation that's used in modern CPU-based architectures is. So, having talked about this, oh, okay, cool. Awesome. You know, I drilled a hole in my floor to get better upload bit rates, so that I could run an Ethernet cable from my basement. So just so you, oh, yep. um, if either of the two cats comes within grasping range, I'll let them on the stream so you can say hello to the kittens. Anyway, so the C programming language. Yeah, it's okay. Okay, one more comment about the chat, and then I'll stop. This laptop that I'm doing this on is actually like a 5-year-old gaming laptop, and it turns out that my graphics card is so old that there are no updates for it anymore. It's not even supported anymore. So, I need a new laptop. Yes, I have 2 cats. They're very nice cats. +1 cats, for sure. Oh no, at least +3 modifier on my cats. So I'm doing this on Linux this time, and Linux seems to be a little bit better. Like, the resolution on the video seems to be, like, the slides are mostly readable most of the time, which is good, because when I was doing this on Windows, it was like, half the time you couldn't even read the dang slides. The video compression was so bad. Anyway, let's talk about the C programming language, the reason that we're all here. So C evolved from 2 previous languages, BCPL and B. BCPL is Basic Combined Programming Language, and was developed in 1967 by Martin Richards as a language for writing operating systems, software, and compilers. Ken Thompson modeled many features of his B language after their counterparts in BCPL, and in 1970 he used B to create early versions of the Unix operating system at Bell Laboratories. So, you can consider the name. If you're wondering why they call C C, it's because it's incremented from B. It's like one better than B, so it's the next letter. It's the next iteration of B. B is super, super old, though, so don't worry about it. The C language was evolved from B by Dennis Ritchie at Bell Laboratories, and was originally implemented in 1972. This means that we are definitely we're trying to learn a language here that's 50 years old. Let me just take a look at the chat, because there seems to be... Okay. Whoever this Trinomon person is who's filling up the chat with emojis and various things, if you don't stop that, I'm going to ban you, because that's not useful or helpful. Yeah, so Bell Laboratories, like Bell the telephone company. Yes, Bell the telephone company. We now know Bell as a telephone company, but they were very highly interested in the development of electronics and computer systems, because it was a way for them to greatly automate their, telephone systems, which were already electronic. Will we be tested on the history of C? Yeah, thank you. Will we be tested on the history of C? What's on this slide? Not generally. This is more informational. Although, I'm not going to completely exclude the possibility, but I certainly, I would recommend spending the majority of your study time learning how to program in C rather than memorizing these types of factual things. I'm really trying to put the programming language in context for you, because it's important for you to understand that this is a language with history. And it's also important to understand that you are about to learn a language that has not really seen very much change over the course of its 50-year history. As we're going to see later, one of the major updates that this language received was the inclusion of Booleans as a data type, and that only occurred in the year 1999. So, yeah. So anyway, C initially became widely known as the development language of the Unix operating system. And if you know anything about your operating system histories, Unix was the basis for Linux. And Linux split itself into all of the Linux distributions that we now know and love. So we're talking about Ubuntu and Debian and Arch and Mint, and all of these distributions have their some of them are based in OpenBSD, some of them are based in Unix, but I believe the majority of them are Unix-based. Many of today's leading operating systems are written in C and or C++, and if not the entire operating system, large chunks of the operating system. And it has to do with the fact that C is such a fast language, an efficient language. Wait, so programming languages hasn't been changed at all. C, not as much. C is like, it does occasionally get updates. Every few years, there are additions to the C standard, which get integrated into the compilers. But no, yeah, if you took a C program that was written in '92, it would execute on today's C compiler. That's like, they make additions to it sometimes, but they don't take anything away. Because one of the very important parts about C is that C programs are back compatible. So, C as a language is mostly hardware independent. That's sort of getting back into that. Yeah, so because the constructs that C uses are very basic and common to most hardware implementations, C is a programming language that travels very, very well across very, very different architectures. Yeah. Yeah, if, Noor, I share your opinion. Some of these guys commenting are maybe not even from the class. So if you guys are not actually in this class, I would ask you to please hold back your comments, especially if they're completely unrelated to the class. This is a class that we're trying to have, and I will use the ban hammer if I have to. Okay? So, with careful design, it is possible to write C programs that are portable to most computers. Applications. So, because of its high performance characteristics, C is still being used quite a lot, despite being 50 years old. In operating systems applications, the portability across many hardware implementations and overall performance lend C to operating system development. Linux, portions of Windows, and Android use C. Apple's OS X uses Objective-C, which is derived from C. That's basically Apple's version of C++. Another hot application of C is embedded systems. Yeah, interesting. All right. Okay. All right. That's enough, guys. I'm looking at what's going on in the chat right now. All right. That's it. You are... Where's the ban on this? You're going to be removed, sir. Oh, that just removes the comment. All right. Let's see you. Come on. Okay, so there we go. And there we go. All right. Yeah. Okay. So there we go. Those messages should no longer appear. Thank you very much. And I think while we'll put you two in a timeout as well. Just to do that. Only 300 seconds. All right. Well, so be it. Yeah. That's so. It shouldn't need to be said, but you know, you shouldn't talk to people like that in any form. Yeah. That's all right. Yeah. Yeah, I believe Swift is Apple as well. Yeah. Yeah, this is a good idea. Okay. So those of you who are in the class, send me an email if you're interested in being a moderator for this stream. I can appoint some of you guys moderators to be able to do this kind of thing for me, so that I can actually just, you know, do the lesson. If you're interested in being a moderator for this course, please send an email to me, and I will set you up so that you can also exercise the ban hammer. Okay? Good. Yeah. I don't think any of the TAs are actually watching this stream, so yeah. Okay. But yes, I believe I'm not an Apple developer, so I'm not super up on all of the Apple biz, as it were, but Swift might be a continuation of Objective-C. I'm not sure. Anyway, so for embedded systems, C is one of the most popular languages because these applications are typically highly memory conservative, which is something that we touched on in the last lecture. So, another application of C is real-time systems. In a real-time system, this is a term you might be hearing for the first time, but a real-time system is like a mission-critical application that requires very fast response times. Think about the software that is in an aircraft. If the software takes too long to make a decision about something, the airplane could possibly not react fast enough to changing air patterns or something, and that could be dangerous to the lives of all of the people in the aircraft. This is an example. This is actually an example of a real-time safety critical system. But any application where there are strict timing requirements, regardless of whether it has an impact on human life, these are known as real-time systems. High-performance languages dramatically increase the feasibility of meeting timing constraints. Because C is so simple, it runs very fast. And because it runs very fast, it is applicable to these types of real-time systems. Another application of C is when you have extremely high quantities of operations that you need to perform. So as we discussed in the previous lecture, if you can perform for every operation that you shave off of something that's run many, many, many times, you are saving not only time but energy. In a lot of these applications, like if you take a look at servers, like a server farm, like one of Google's server farms, right? Every operation that a CPU executes has a certain amount of heat, like heat energy that is produced from the actual electronics that has to be dealt with by the server farm. This is why server farms are typically inside of air-conditioned buildings, and the air conditioning costs of a server farm are directly proportional to the number of CPU operations which are being executed by the computers in that server farm. So, if you are using a language that minimizes the number of operations that need to occur, that has a direct impact on the amount of money that your company has to spend cooling the servers. So, that's another application of these types of languages. And interestingly enough, this is a graph from the TIOBE Programming Community Index. This is a measurement. This is an index that's kept of the popularity of programming languages. The mechanism by which they determine whether a language is popular is how much people are searching how to use it, which I think is a pretty good measure, actually. So, if you take a look, this top line here, this is Java, this black line. This light blue line right underneath Java, this is C. So you can see, that although there's a dip around 2017, right now, C is the most popular programming language in the world, or at the very least, it's the programming language that nobody knows how to use, but everybody has to use, which is why they're Googling it. But some of the other contenders are Python. You can see Python's had a pretty good uptick in the last 2 years. C++, a little bit down, but still a strong contender. Visual Basic and C# are just about tied. I think one's over top of the other. SQL's there. PHP is there. PHP, you can see, has been on a steady downward decline for about a decade. But the interesting one is R. So R is a programming language used for statistical analysis, and it has been on a steady uptick this entire year. But anyway, if you're interested in that sort of thing, go to www.tiobe.com and you can check out all kinds of interesting statistics about the popularity of programming languages. But this should indicate to you that learning C is worth your time. So, let's talk about standards. Because, it's good to have standards. Is C more portable than C++? Good question. I don't think so. I believe C++ is also... so, it's tricky. I'm not a super efficient user of C++. I haven't really used it very much in, my real life. So I can't. I will be more able to speak to these types of things once I've written the slides for the C++ part of this course. But my impression of C++ is that it is C with better abstraction mechanisms. So if C++ is built completely on top of C, i.e., if it's built on top of the base machine code that C is built off of, it just has some more complex syntactic and semantic structures, then it shouldn't affect the issue of portability. It might affect the issue of runtime. C++ probably suffers from the same thing that Java does, in that it's not as efficient as C because it's got more complex stuff going on in it. But The issue of portability shouldn't really be, it shouldn't be a consideration. Like many of the, like on this list, C is very, very portable, Java is very portable, Python is very portable, C++ is very portable. Visual Basic, I think that's less portable, but still reasonably portable. Like all of the really big languages, part of what they, yeah. Yeah, C++ is a higher level language than C for sure. It's got, like, yeah, we'll get into it. We'll get into it. Let me talk about standards. So the semantics of the C language are set by the International Standards Organization, or ISO, and the International Electrotechnical Commission. Oh my god, I'm getting a phone call. I'm not getting a phone call during a lecture. Thank you very much, folks. Jesus Christ, is there anything that's going to go right with today's lecture today? Anyway, the International Electrotechnical Commission, in a series of standard documents, which you can look up. If you're interested, you can get them through the library. Normally you have to pay money for them, but because you're a student, you get them for free. The most recent one is C18, which is ISO/ECE 9899:2018. You can get the actual document here, and that is the latest version of C. There are many C compilers, which are all implementations of the above standard. The following compilers are compliant with the latest version of the standard. You've got GCC 8.1.0, LLVM Clang 7.0.0, and IAR EWARM version 8.40.1. You don't have to memorize those. All you should really know is use the most current version of GCC and you'll be fine. But yeah, so there's an important distinction to be made though. You have a document that says how C is to be implemented. Then you have all kinds of companies and vendors that all have to make their compiler from that document. Whether or not their compiler is compliant with that document doesn't necessarily mean that they're not offering the product, if that makes sense. Like there will be C compilers out there that are compliant with like the 2014 version of C that just haven't been updated for 2018 yet. What's a GNU compiler? So the GNU compiler, GCC, is just it is a program that compiles it's a program that compiles C, the new project C and C++ compiler. If you give it a C file, it compiles it to C. If you give it C++, it'll compile to the other one. For those of you who have never seen a man page before, this is a man page. I've already spoken to the issue of compatibility. That compatibility and portability are the same thing. So, the GCC, this is a compiler that you will. This is the compiler that you will typically be using. If you're not using it specifically through the command line, then you will likely as not be using it through some, GUI or something that's referencing GCC in the back end. But yeah, so yeah, what C is regulated by international commissions, and whether or not a particular organization's compiler is compliant with it actually is a thing that's tested. Like many other languages, the unit of abstraction in C is the function. The most commonly used functions are collected into the C. Yeah, I think. Yeah. Man, I do need to. Yep. Yeah, if this continues, then I'm going to have to start setting these to private, which I don't. They'll be public after the stream, but yeah, I might have. This is making me consider whether I need to adjust the privacy settings on these videos to keep these kind of jokers out. My God, though. No, I don't think Piazza would be a good platform for this. Yeah, no, I don't think YouTube is a bad platform for this. I just may have to start setting these videos to private. If I set them to private, then I'm gonna have to post the link to the stream in the Avenue announcements or something like that in order to for you guys to all get access to it. But yeah, unlisted. That's what I meant. Yeah, always gets me the difference between private and unlisted videos. Yeah. Okay. I think we'll try. I'd like to try if having maybe a couple of you guys as moderators. See if that solves the problem. But if that doesn't solve the problem, then I think we'll move to the more extreme measure, which would be unlisting the videos. Okay? Okay, cool. And the pace is good today. I'm glad. Yeah. Maybe I'll have a like a poll or something. I can set up polls on Avenue. See which solution is preferred by the class. I do agree that this is like what's its two's company but three's a crowd, something like that. And like, yeah, 3 people is too many people to have this going on with. Like normally I don't really care that much about chat, but that guy was just being abusive, and there's no reason that we have to listen to that garbage. So, all right. Anyway, so talking back to C. So this is not something that's highly different from what your experience of Python has been. The fundamental unit of abstraction in C is the function. Unlike in Python, you don't have classes. That's what makes Python an object-oriented language and C not an object-oriented language. C is not an object-oriented language because it doesn't support the existence of objects. Or maybe we could do unlisted and have moderators. That would also work. To the issue of why not to use the MS Teams, I really like the fact that YouTube will automatically make the video available to you guys. Like they are doing the recording right now on their servers, and I don't really have to touch it very much. Yeah, structs are not objects, though. There's a difference. A struct is just an arrangement of data. It doesn't have any methods attached to it. So you can they're not quite the same thing. Anyway, so the most commonly used functions are collected into the C standard library. We are going to be using that a lot this semester. The documentation for the C standard library can be found at that link that's missing the HTTPS for some gosh darned reason. Use of library functions is strongly encouraged. The library functions in the C standard library have had decades of optimization and improvement. So they are definitely going to be better than anything that you can come up with. However, that's if you want to re-implement something for the purposes of your own education, you're absolutely, please, go ahead. I'm not trying to discourage you from writing your own code. I'm just saying that the library functions are very, very good, and you should use them. So, rule 1, if a library function exists, you should use it. Rule number 2, learn rule number 1 quickly. What is an easy way to learn the syntax? Taking this class. Yeah. Take this class. Tune into next week's lectures, and you will learn C syntax. That's the entire next lecture is C syntax. So now let's talk about a few C-based languages. Languages that are, have either been developed from C or have drawn heavy inspiration from C. So C++ is the obvious one to go to. C++ was developed by Bjarne Stroustrup at Bell Laboratories, again at Bell Laboratories. It is an iterative improvement on C, crucially adding support for object-oriented programming, which C doesn't have. Object-oriented design adds the object, a new unit of abstraction that allows the combination of data with functions. This increases modularization and facilitates programming principles, which allow very large programs, I can see I have a spelling error there, to still be manageable. So, the size that a program can become is proportional to how well its abstraction mechanisms work. C is really good for writing small, compact programs, but if you want to write this massive magnum opus that has 50 people working on it, probably you don't want to be doing it in C. So, some other ones. Objective-C is an object-oriented language developed by in the early 80s and eventually acquired by Apple. So Apple didn't actually invent Objective-C, they just acquired it. Very clever of them. It kind of does what it says in the name. Java is a C++-derived language developed by Sun Microsystems in 1991. It uses the Java virtual machine to extend portability to a massive number of highly diverse systems and architectures. Also, Minecraft was made in Java. Thank you. I like my headset too. C# is Microsoft's .NET framework is C# essentially. They're roughly the same thing. It integrates with internet connectivity into a framework of both Java and C++. So C++ draws information from Java or C# draws inspiration from both Java and C++. Non-Microsoft implementations of C# also exist, such as the game object scripting in the Unity game engine, which is a particular Some other ones. PHP, an object-oriented open-source scripting language used primarily in Internet database and Internet database applications, because those are different things. Python is a C-based language. It was released in 1991 and developed by Guido van Rossum. Python emphasizes the elimination of superfluous syntactic detail and has become a very popular language for introductory programming courses, such as the ones that you've probably taken. JavaScript is the most widely used scripting language and adds dynamic behavior to web pages. And I have a comic. If you guys want to read the comic, I'm going to let you pause the video because I think I might be able to finish this off in the next 10 minutes. So I'm going to skip reading the comic, but you can pause the video and read the comic if you like. So, compilers then. In contrast to Python, that we all know and love from 1D04, C is a compiled rather than an interpreted language. The big difference between a compiled language and an interpreted language is that a compiled language has to read the entire program up front and then create an executable that is then executed. an interpreted language is a framework in which... Oh my god, is this more of this? My goodness. Is there a programming language not built off C? Yes. Haskell. Haskell is not built off C. Okay. So, what was I talking about? Yes, so the difference between compiled and interpreted languages. In Python, what's actually happening is that you have the Python interpreter process that's running, and executing the script means taking the statements from the Python script, feeding them one by one into the interpreter, and then the interpreter processes those statements one by one. There's a layer of software that exists between the script itself and the CPU. Whereas, it's kind of similar to the Java virtual machine. With C, you take a source code file, you give it to a compiler. Okay, so let's actually go through these points. The first thing you have to do is you have to edit your C program. You have to create the program itself. You give it to the compiler. The compiler pre-processes it, which means includes functions from other libraries and performs various types of operations like macro substitution. It then enters parsing, where the program is broken down by its grammar into its constituent elements. It is then assembled into a assembly-like language, intermediate language, that can be translated directly into the machine code of the system that it's being compiled for. You then have a linking process, which hooks up all of the various functions that are going on, that you're referencing in the script, because not all of them are going to be, or in the program, not all of them are going to be contained in the program. Like when you're using library functions, you have to link to them at some point in the compilation process. You then load that program, and that's you doing that. You have to load the program to be executed, and then it has to execute. So, editing a C file. This is how you do it. We're going to go through all of that in like the next few slides are going through these 7 points in detail. So if you'll just be patient with us, then we'll get there. So, to edit a C file can be created using any plain text editor. Common ones include Notepad or Notepad++ on Windows, Emacs, Gedit, or Vim on Linux, and TextEdit on Macintosh systems. And I am going to call it a Macintosh system. So if you want to see what Emacs looks like, this is Emacs. It's just a text editor. Hello. But it's got a bunch of really crazy commands for saving. Like Emacs is the text editor that thinks it's an operating system. If you want an easy-to-use one in Linux, I would recommend Gedit. It's the Linux equivalent of Notepad, if you're using Linux. Fancier environments, such as Jupyter and Visual Studio Code, allow for compilation and execution of C programs within the editor itself. So if you want like a self-contained solution, Jupyter or VS Code are the way to go. C files are given the .c file extension, and C header files, which are a thing we'll get to, have the .h extension. Typically, the libraries from the standard library that you will be loading in are going to be .h files. Oh my god. So, in order to invoke the C compiler, let's go through the process. So I'm just going to, let's see, am I going to make a, yeah, I'll show you how to do this real quick. So 2MP3 code, sure, open in terminal. There we go. So simple.c, I believe that's, nope, this has got other junk in it. I'm just going to delete the other junk. So this is a C program. Very simple. This is your Hello World program in C. Save that up. In order to invoke the C compiler, you type gcc simple.c, i.e. the file name, and if you wish to specify the name of of the generated executable, you use -o, the output flag, and you type whatever name. So I'm going to call it simple. There you go. And that compiles it. If you want to view all of the warnings that will be generated by GCC, and GCC can get quite a few warnings. This program doesn't generate any warnings, but if you want to see them, use the WALL flag. Cool. My God. So this is actually a prompt here. I know it doesn't look like it because it's sort of, yeah, there we go. So if you wish to execute the executable, you use / and then the name of the executable. And you can see that we have produced Hello World. That's how you, that's the whole process with respect to doing things in bash prompts. So there's a return 0 in here, but that's not necessary in all cases. So again, to compile this program, we use the following command in bash, which is the one that I used. First, we invoke GCC, the GNU compiler collection. GCC knows we want to interpret the file as a C program because of the file extension. If it was .cpp, that would be C++. Next, we specify the file to be compiled. The O flag allows us to specify the name of the produced executable file. The produced file is the original program expressed in machine language, which is also known as object code. Note that this is different from assembly language. And we're probably not going to finish this lecture. We'll have to resume this on Monday, but let's see if we can get through the next 2 slides. So, once the compiler is invoked, it goes through a couple of stages. Preprocessing. The purpose of preprocessing is to get the code ready for parsing and generation. This includes removing all of the comments, expanding any macros, expanding any included code. You may notice here that this line includes std.io. We're going to talk about that in slide set 2 in detail. And next, pardon me, where were we? This was the one, okay. And it does a few other things as well, which, you know, we're gonna get there. The next step is parsing. The code is then broken down into tokens. This is also known as tokenization. These tokens are arranged into a hierarchical abstract syntax tree. So if you have a if statement, it's got statements that it contains. Those statements contain expressions. Expressions can contain variable names or literals. It's a whole hierarchical organization, and the purpose of tokenization is the construction of the abstract syntax tree. During assembly, the abstract syntax tree is used to generate a series of machine code instructions which are saved as an object file, star.o. During the linking phase, the object file is linked up with all of the relevant libraries, and the executable is produced. So some compilers are smart enough, if you have several C files and you're importing some of your own C files, some compilers are smart enough to go looking for the other files and compile them if they need to be compiled, and then link them automatically. Things may have changed since I was a wee lad taking C back in my bachelor's degree, but I believe in C programming this is something that you do manually or automate using makefiles. And makefiles are certainly a thing that we're going to have to talk about sooner or later. God. All right. Here comes the banhammer guy. Oh, like, class is over anyway. All right. Yep. So, congratulations, all of you people who have been filling up the chat with all of this nonsense. Stronger measures are going to need to be taken, and I'm going to take them. I apologize to all of the people who are trying to, use this class usefully. This is not the time to be, yeah, okay, we're going to do something about the chat. It's sad, because when it works pretty well. Okay, anyway, that's going to be it for today, folks. Thank you very much for your time and attention. And anybody who's interested in moderating, please send me an email.